Hello all, I am Dr. Gitanjali Mehta, Associate Professor, School of Electrical Electronics and Communication Engineering. And I'm going to have an introduction here to the subject power electronics. So after completing this lecture, the student should be able to do the following. Describe what is power electronics, list the applications of power electronics, describe the evolution of power electronics, list the major types of power converters, and list the major parts of the different power electronic equipment. Moving on to the next slide. What is power electronics? First thing is that power electronics has revolutionized the concept of power control for power conversion and for control of electrical motor drives. Power electronics combines the terms power, electronics, and control. Control deals with the steady state and dynamic characteristics of a closed loop system. Power deals with the static and rotating power equipment for the generation, transmission, and distribution of electric energy. Electronics deals with the solid state devices and circuits for signal processing to meet the desired control objectives. So, power electronics may be defined as the application of solid state electronics for the control and conversion of electric power. Further, there is another way to define power electronics. One could also define power electronics as the art of converting electrical energy from one form to another in an efficient, clean, compact, and robust manner for the energy utilization to meet the desired needs. Power electronics is based primarily on the switching of power semiconductor devices. With the development of power semiconductor technology, the power handling capabilities and the switching speed of the power devices have improved tremendously. The development of microprocessors and microcomputer technology has a great impact on the control and synthesizing the control strategy for the power semiconductor devices. Modern power electronic equipments uses power semiconductors that can be regarded as the muscle and microelectronics that have the power and intelligence of a brain. Power electronics is already found in an important place in modern technology and is now used in a great variety of high power products, including heat controls, light controls, motor controls, power supplies, vehicle propulsion system, and HVDC, that is high voltage direct current systems. Here you can see some applications of the power electronics. Coming to the history of power electronics, it began with the introduction of the Mercury arc rectifier in 1900. Then the metal tank rectifier, grid controlled vacuum tube rectifier, ignitron, fanetron, and tharatron were introduced gradually. These devices were applied for power control until the 1950s. The first electronics revolution began in the year 1948 with the invention of the silicon transistor at Bell Telephone Laboratories by Bardeen, Patian, and Shockley. Most of the today's advanced electronic technologies are traceable to that invention. Modern microelectronics evolved over the years from silicon semiconductors. The next breakthrough in 1956 was also from the Bell Laboratories, the invention of the PNPN triggering transistor, which was defined as a thyristor or a silicon control rectifier SCR. The circuit electronics revolution began in 1958 with the development of the commercial thyristor by General Electronics Company. That was the beginning of a new era of power electronics. Since then, many different semiconductor devices and conversion techniques have been introduced. So, the power electronics revolution has gained momentum since the late 1980s and early 1990s. With the increasing energy demands around the world, there is a new era of renewable energy. Power electronics is an integral part of renewable energy for its transmission, distribution, and storage. The research and development for energy efficient automobiles will also lead to increased applications and development of power electronics. Over the years, there has been a tremendous development of power semiconductor devices. Hence, silicon based devices have almost reached their limits. Due to research and development during recent years, silicon carbide, that is SiC power electronics, has gone from being a promising future technology to being a potent alternative to the state of art silicon technology in high efficient, high frequency, and high temperature applications. The silicon carbide power electronics has higher voltage ratings, lower voltage drops, higher maximum temperatures, and higher thermal conductivities. Manufacturers are capable of developing and processing high quality transistors at costs that permit introduction of new products in application areas where the benefits of silicon carbide technology has significant system advantages. A new era of power electronics has been initiated. It is the beginning of the third revolution of power electronics in the area of renewable energy processing and energy savings around the world. Next, coming to the types of the power electronic circuits. For the control of electric power or power conditioning, the conversion of electric power from one form to another is necessary, and the switching characteristics of the power devices permit their conversions. The static power converters perform their functions of power conversion. A converter may be considered as a switching matrix in which one or more switches are turned on and connected to the supply source in order to obtain the desired output voltage or current. The power electronic circuits can be classified into six types. First is the diode rectifiers, that is the uncontrolled rectifiers. Second one is DC to DC converters, which is also known as the DC choppers. Third one is the DC to AC converters. Those are also called as inverters. Fourth is AC to DC converters, known as the controlled rectifiers. Fifth is AC to AC converters, also known as the AC voltage controllers. And then there are the static switches. So the switching devices in the following converters are used to illustrate the basic principle only. The actual converters can be performed by more than one of the above devices. So the choice of the particular device depends upon the switching frequency and the power requirement of the converters. So in this particular figure, you can see the different types of power electronics converters. First is the AC to DC converter, in which the input source is an AC and we require to run a DC load. So we use an AC to DC converter, that is also called as a rectifier. It is also clear from the converter symbol shown here. Further, we have to DC converter, also known as the chopper, in which constant DC can be changed to a variable DC or a variable DC to a constant DC depending upon our requirement. Next is the DC to AC converter, also known as the inverter, in which we can convert the DC to an AC of desired output voltage and frequency. Also can be seen in the converter symbol here. Fourth one is the AC to AC converter, which can either be an AC voltage controller or a cyclo converter or matrix converter, in which AC of desired frequency and or magnitude from generally the line supply AC is converted into the required form of AC. So coming to the summary, we have discussed what is power electronics, the applications of power electronics, the history of power electronics, the types of power converters. The books that we are referring here is Power Electronic Devices, Circuits and Applications by Mohammed H. Rashid, that is PHI publication. Power Electronics by Ned Mohan, John Willey and Sons. Power Electronics by P.S. Bhimrao Khana Publications. Principles and Elements of Power Electronics by Barry Williams. Power Electronics Essentials and Applications by L. Umanan, Willey Publication. Power Electronics Daniel W. Hart, Tata McGraw-Hill. Then Fundamentals of Power Electronics by Erickson and Spencer. So thank you all.